Classroom Under the Sea is made possible through the generous support of Diversity in Aquatics, the project's official sponsor. To learn more, please visit diversityiнаquatics.com. Additional support comes from the Roane County United Way. Classroom Under the Sea is presented by the Marine Resources Development Foundation on Key Largo in the Florida Keys, and Roane State Community College, one of Tennessee's community colleges.
Well, hello, you have company.
Welcome,
Hello.
welcome. Good to see you.
Hey, we're here. We made it.
We are here.
Yay!
A long excursion.
The long dive down.
Hello!
Yeah.
Welcome down.
Hey,
Classroom
how
Under
you
the Sea.
doing?
Good to see you.
What's the procedure here? Take off.
Our guests will join us for Classroom Under the Sea right after this. Welcome to Classroom Under the Sea. I'm Jessica Fain with Roane State Community College, and we are broadcasting live in Jules Undersea Lodge here in Key Largo, Florida. If you hear some background noise, that's just our live support systems. If you have any questions or comments in today's broadcast, please feel free to post them to our Classroom Under the Sea Facebook page or our Twitter account using hashtag Classroom Under the Sea. Today we're going to be talking about coral restoration, and I have two guests with me. I have Mr. Ken Nedimyer, who is the founder and president of Coral Restoration Foundation, and I've got Dr. Dave Vaughan, who is the director of Mote Marine Laboratory here in the Keys. Welcome, guys.
Hey, how you doing?
Good. I'm glad you guys were able to join us.
We're sitting in your living room right now.
Yes, in my actual living room.
Yep.
And it was a great entrance to get into the living room.
Yes.
Different than most people's homes.
A little unique. Well, it's very similar to what you guys do for your jobs. You have to go out and get in the water for your jobs.
That's right.
So it's similar to that.
That's true.
All right, guys. So, Ken, I'm going to start with you. Can you tell me a little bit more about the Coral Restoration Foundation?
We're a nonprofit, and we're focused on developing effective ways to grow corals and then to restore coral reefs. All of our coral nursery work is done offshore, underwater. So we have, in the Keys, we have 5 different nurseries. They're usually 3 miles offshore. And we grow thousands and thousands of corals. We have about 40,000 corals growing in our offshore nurseries right now. And when the corals get big enough to put on the reef, we cut them off our trees, and you'll see what I mean in a little bit, and glue them down onto the reef. So it's a very dynamic thing. We use a lot of volunteers, a lot of students, a lot of recreational divers. It's all dive oriented. So.
All right, and then Dave, what does the Mote Marine Lab do with corals?
Well, we do a program very similar to Ken's that he initiated early on, that we were part of a partnership for a staghorn nursery program. But we also work with the other, I sometimes call them the orphan species of coral, the other 26 species that form the reef building corals, some things that you're familiar with like brain coral, boulder coral, the big massive corals. And we do that on land first, and inside and outdoor tanks, and then we propagate them and then move them back onto the roof in a similar way.
Okay, so you do soft corals and the orphan corals, or the building corals, and then you do the branching corals like the elkhorn and the stag corals.
Mostly branching corals, yes.
All right, so for our viewers, can you tell me exactly what are corals and why are they important?
Well, a coral is basically an animal. A lot of people think they're a rock because they look like a rock, and they form, the skeleton forms what appears to be a rock, but it's an animal that lives on the outside of that rock, a real thin layer of like jelly on the outside of that. And it's more than just an animal. It's a bacterial community that is part of it, and it's also an algae, a symbiotic algae that lives in the tissues of the coral. So the coral by itself tends to be, it's not just a by itself type of a critter. It's a community. It's a community of algae, bacteria, and the animal itself. But what you're looking at is generally the animal of the coral. Dave could probably jump into that a little bit more.
Answering the typical
Dr.
question
Dave.
that some people have is it animal, vegetable, or mineral? And I say yes, yes, yes.
All three.
And it
yeah.
really is all three. It's unique in that what we picture as just a living rock is part animal, as Ken said, part plant in a type of algae that lives inside it. And it actually secretes and grows its own mineralization in form of calcium carbonate that forms the actual skeletal part that we know of as a coral reef.
Okay. So, Ken, can you talk us through why we're in this position now? What happened to our corals? Where were they in the 70s versus where are we now?
Yeah, well, I mean, that's kind of, I started diving down here in 1969 in the Florida Keys, and it was a beautiful, magical place that a lot of people, Dave and my age, we watched, Jacques Cousteau, The Adventures of Jacques Cousteau when we were kids, and we wanted to do that. At least some of us did. I did.
Absolutely.
And so as soon as I had the opportunity to start diving, I came down to the Florida Keys because I could drive there, and just started immersing myself in the Florida Keys and then in coral reefs, and it was beautiful back then. But then over a period of years, I actually went to college, moved down here after college, and it was still really great, and then things just started to happen. The reef started dying, just a lot of different things happening, and I became real concerned about it. And over the years, I realized I can't continue. I was a tropical fish collector for a long time, so I realized I can't continue to collect tropical fish if there's no place for the fish to live. So I kind of took action, and that's kind of what led me to do what I'm doing now. But the reefs have died from a lot of different things, a lot of stressors. Sometimes they're one-off things. Sometimes you get in the 1970s, late 70s, and then in 2010. We had just terrible cold fronts where the water got into the the 50s, 40s inshore, and it killed a lot of coral. And so you have huge effects of an event like that, and then just over time, other things happen, and the corals have died.
And I think you've got some great pictures that kind of show what the corals used to look like in the 60s and 70s and now, right?
Sure, I could. There's a picture coming up, and this is a picture taken in the 1970s, Carey's Fort Reef, and you can see the elkhorn coral, staghorn coral. You can see what it used to look like, and you move forward 10 years or 15 years, and the staghorn coral has all died. There's still a brain coral or actual star coral where the person is snorkeling, but the other corals have all died. You move forward a few more years, and sea fans and soft corals have replaced all the hard coral. This coral head was still there, but it's dead too. Here's another sequence coming up. This is a brain coral, and you can see staghorn coral all around the outside of it. This was a common scene. Move forward a few years, the staghorn coral has all died, the elkhorn coral has died. The brain coral's still there, but it's struggling, and you just keep moving forward a few more years, and that stuff has all disappeared, and you just you see that's what it looks like now. And people come to the Florida Keys, and they don't envision that the staghorn coral was ever just all over the place like it was back then, and that was in my lifetime. It's changed so much since then, and I've seen it happen, and I realized there's got to be something we can do about it. I was in the aquarium industry, so I saw these aquarists growing this stuff like weeds in their home aquariums, and I thought, wow, if they can do it in a home aquarium, surely we could do it in the ocean. And that's what motivated me, and I ended up with a live rock farm, which was this patch of land I was leasing out in the ocean, and I was growing live rock for public, for aquariums, and coral started settling on the rock, and then next thing you knew, I was growing coral instead of just live rock, and it turned. And I was growing it I thought I was going to grow it to make money, and I realized shortly that I wasn't going to make any money at it, but I was having a really good time doing it, and I got this vision of what if we could grow enough to replant a local reef, and so we started doing that, and just one thing led to another. It was a whole change of life for me, but it was pretty exciting.
So, Dave, why is it important to have this coral? Why is it important that we're trying to rebuild the coral systems that we have?
Well, I had a very similar experience to Ken in that I grew up in actually the science research area, and we moved into looking at marine ornamentals for the aquarium trade and started working on fish such as clownfish and dottybacks and gobies. And I was so proud that we were producing so many for the aquarium trade that didn't have to come from overseas from off of the reef. that we decided to expand into branching corals from the Pacific. And that became so successful, providing these types of corals in a land-based system for the aquarium trade, that finally I had the grandson of Jacques Cousteau, Philippe, and his sister Alexandra come visit. And when I showed him all the corals I was so proud of growing for the aquarium trade, Philippe put his hand on my shoulder and he said, "You missed the point, Dave." I said, "What?" He had a big smile. He said, "You could do this for the reef." And that's when I switched gears and came down to the Keys and started working with Mote Marine Lab to try to grow corals, to do exactly what Ken's dream was as well. And put these back on a small area, and the two of us over the past 10 years have learned some ways to actually grow a lot of corals very fast, and it's making a difference. And the big difference is that people say, "So what? What about the reef?" And most people don't realize, like those pictures Ken showed, we've lost 25% at least of the world's corals in just our lifetime. And then most of the types of reasons are from climate change to pollution to a whole dozen pieces, but climate change seems to be the biggie. That can be cold temperatures, like Ken said. It could be hot temperatures, which causes bleaching. But here in the Keys, this industry of the reef is responsible for most of our economy. People come here to dive, they come here to catch fish, they come here to catch lobsters, and they come here to snorkel, and they come there to enjoy it. It's literally worth over $1 billion in this county alone, probably $4 to $6 billion in South Florida. It's really important for not just looking at it, but it's the living resource of our underwater forests.
So, to me, it's really important to keep the coral reefs. As a diver, like you said, people come here to visit. But also, like you said, the fish. This is what they use as their home, their food source for some fish. So without these corals, we lose all kinds of species of fish. And a couple weeks ago, we actually talked to, we were talking about the lionfish, and we were talking about how the lionfish is wiping out the fish. Well, if the corals die, we don't really have to worry about the lionfish because we're not going to have any fish for those to feed on. And that's really important. And what Bruce and I, for Classroom Under the Sea, what we're trying to get across to people is this stuff is important not only for people who live here, but it's important for people across the country and across the world. And one of the points that I like to make is if we lose the fish out on the reef, we lose dinner a lot of times in fancy restaurants. I mean, snapper, grouper, all those fish are on the menus at a lot of restaurants. And so if the corals are definitely something that we need to protect.
That's exactly right. Somebody came up a couple years ago and said, in the next 10 years or so, we may lose 40% of our fisheries. And I thought, oh, how could that be? We won't be that stupid to allow that to happen with management. But I didn't realize that even though coral reefs are only less than 1% of the world's oceans, they're responsible for 24 to 40% of the world's fisheries. So there are underwater forests, there are underwater jungles, and without those we won't have the jungle animals and the forest animals. So if we lose our coral reefs, as you said, it's going to make a big impact, not on just people who like to dive them.
Right, not just Florida people, but every people.
But everybody around the world, exactly.
All right, so can you tell me exactly how you grow these corals? Are there some specific techniques that you use, or?
Well, some people might say corals don't grow on trees, but we found that they do grow on trees. I started growing them in it was 12, 13 years ago. My daughter and I had a 4-H project, and we started growing them first we grew them on just little rocks, and then we grew them on little concrete discs that we made out of, that was made out of concrete. They were like a little hockey puck. And we could grow them on a little disc and they would do fine, and we grew them on disc, and there's a lot of ways you can grow coral, and there's some ways that it'll grow more effectively than other ways. And one thing we found is when they're suspended, there's a picture coming up, that's when we were growing them on discs. And you can see the discs are each labeled and there's a number on them, and we were keeping track of the genetic strains of these different corals. We thought it was important. It is important, it's real important to keep track of the different genotypes. We can get into that more if you want later. But what we found is that there's a ton of work to clean them like that. We had to always scrub those discs and things like that. So we got this idea of suspending them from lines. There are people in the Caribbean were doing that, and we thought, well, you know, if they can do it there, we could try it here. We tried it and found out that the corals grow really fast, and it's really easy to take care of them. There's just a thin piece of monofilament to clean. And so we started growing them on these clotheslines and having a lot of success with that. But we ran into an issue with the federal government and the sanctuary. They were concerned that if we I had 8 line nurseries like this at our nursery, and we were growing a lot of coral, and I said, oh, this is great. So I want to put 20 more lines down at our nursery. And they said, oh, wait a minute. So they started getting really nervous because the potential for entanglement from a turtle. They said turtles, manatees, and dolphins. Those are the ones that are protected animals. They're under, they're all endangered. And so what if, they get tangled up in these lines? If you have the whole nursery full of lines like that, and a dolphin or a manatee or a turtle got in there, they could get tangled up. And I was never worried about a dolphin getting tangled up in there, and we don't have manatees out there. But a turtle was the real thing, and I thought, it'd be awful to come out here with CNN News or CBS News doing a thing. We all splash in the water, and there's a turtle all tangled up with lobster with lines wrapped all around it. So so what if we could grow them? We got to come up with a way to suspend them without causing an entanglement hazard. So we came up with this idea of building a tree and suspending the individual corals from the branches of a tree. And our first one was made out of PVC pipe. It was actually a really cold day in February, and we were contemplating this problem of the line nurseries and where, how to beat this. And so we were drinking coffee. It was just, it was cold, drinking coffee. Pretty soon you wanted to do something. I had a whole box full of PVC pipes and parts downstairs. So we made our own first couple of trees that day out of what was downstairs. And that picture was one of them. And then we've refined it since then. We've used fiberglass arms, and we've gotten fairly sophisticated. So this picture, the next picture, you can see that we've hung the previous one. She jumped the gun on that. So this is just an idea of the branches each have a whole bunch of little holes in the arms, and we hang little corals. These are just little fragments of coral that are cut from a parent colony. Now, a parent colony is usually something we already have growing in the nursery. If not, we might have gone out, so sometimes where do you get your corals to start with? Well, we get permission to do it first of all. You don't just go out and start grabbing corals. And we had to get permission from the federal government, from the National Marine Sanctuary, from the state of Florida, from all, from your grandmother almost, to go out and collect these corals. And we bring them back to the nursery. And once we do a collection, usually if I collect a genetic strain of coral, a patch reef might have one genetic strain, it might have 5, but usually only has 1. And so we would collect that one, some pieces of it, take it back to the nursery, hang it up, and then it would grow out. We cut that original piece into more pieces after 6 or 9 months, and then keep cutting it, it'd grow out, keep cutting it, grow out. And you can kind of see here on the bottom there's some bigger corals. We've been cutting those up, and then the smaller corals up above it are the corals that we've cut from it. So they're all freshly cut, and so those are all basically new trees. And if you move to the next slide, that's the same group of trees about 9 months later, and you can see they've, even on the bottom, this bottom one there has gotten huge. I mean, they grow like crazy weeds, and so we're just growing fragments. The fragments grow out, and when they get about a year old, we cut them off, drop them down to the bottom, bundle them up, tag them, take them out to the reef and plant them.
So this is very similar to like plant propagation, asexual reproduction of plants.
It's a lot like that.
A parent plant, and you take a cutting, and then that cutting grows roots and grows into a mature plant, and then you can do the same thing multiple times.
Right, and so we can do a one-time collection of any particular genetic strain and then never have to collect from that area again. As a matter of fact, we can put more coral back onto that patch reef in 2 years' time than was ever there. So we can take one pinky-sized coral, turning into a ball of coral like that in a year, cut that into 100 pieces, and have 100 balls in 2 years. So it goes that fast. When we started suspending them, for some reason we found they grow 2 to 3 times as fast as when we were growing them on those discs. So it's just been a whole game changer on how to grow coral.
Now, because you're taking cuttings from a parent coral, they are going to be genetically
They're all
identical,
clones, yeah.
Right. Are you worried at all about diseases coming in and being able to wipe them out?
So we have in our Tavernier nursery, we have I think 110 different genetic strains of staghorn coral, and we keep track of them. So you might have a whole row, it might be 3 or 4 trees, it might be 10 trees. They're all genetically identical, and then the next row over is a different genetic strain. So sometimes you have a disease outbreak in one genetic strain, but it doesn't necessarily spread into the next one, and sometimes it does. And so we're always, it's a constant issue to be watching for disease transmission, and that's why the nursery is spread way out. I mean, you don't have, the trees aren't touching each other. They're spread out as far as we can reasonably spread them out without having a marathon swim to go take care of the nursery. So.
And these branching corals, you say, grow pretty fast. I think of corals, and I was always, told that they grow really, really slow. And some of them do grow really slow, but branching corals specifically, do those grow pretty fast?
They grow really fast. I mean, we did some work in the Keys and in Bonaire. We had 5-centimeter cuttings, which is the size of your pinky. And those pinky-sized cuttings would get to about 150 to 170 centimeters in 14 months. So in about a year, you're going to 150 centimeters from a 5-centimeter thing. So it's incredible how fast they grow. And so when you start to that, you realize you can grow a lot of coral in a short period of time, and we've done just that. And there's other corals. The elkhorn coral that we're working with doesn't grow quite as fast, but it does grow pretty fast. And so we cut that into little pieces and do the same type of work in there, and we've gotten really good at growing lots and lots of elkhorn coral too.
And then on the flip side of that, you work with your orphan corals.
Yeah, so Dave grows with the boulder corals that grow a lot slower.
So how do you do this? I mean, obviously you're not hanging boulder corals from trees. How do you grow your corals?
Everybody really got their first start with the kind of technique that Ken's doing with the branching corals, the staghorns. And that was really the first launching of showing that corals can grow in our lifetime and be able to be planted out in large numbers. And everybody pretty much stayed away from the other 26 species. That's why I call them the orphan corals. But they're just as important as a different type of tree in a forest that makes up a diversity of plants that a forest would be. And also important because they're actually called the reef building corals. It's the massive corals that form these large heads, sometimes the size of a Volkswagen or bigger, that become the base of what builds a reef up. And that's what we've got to be very important to watch. And so we started growing these indoors in aquarium tanks and found that the 1 or 2 millimeters, that is just about the size of a head of a pin that they usually extend out in lateral growth a year, we were getting a little bit better production than that. But what we did find out by sometimes call it a eureka mistake, is that if we cut these corals into very, very tiny pieces, or micro-fragments as we now call them, it actually stimulates them to grow very fast. As was said with the branching corals, if you prune a branching coral, it makes more branches and it starts to grow faster. Well, we found the same thing with the boulder corals. If we fragment them instead of into a 1 or 2 inch piece, we fragment them into something about a 1/4 inch in size, just 1 or 2 polyps, they grow about the same size as it would have taken 1 or 2 years in just 3 or 4 months.
That's incredible.
And this is pretty much brand new type of astonishment for us. It took us 6 years to go from a few dozen pieces to 600 pieces, but in just the past 1 or 2 years, we've produced 6,000 or 7,000 pieces using this newer technique. And because these are the same clones as you mentioned before, we keep track of also different genetic strains, and the clones from the same parent, we found that when they grow very fast and we had them next to each other, instead of corals fighting, which they usually will do, except ones from the same parent did not fight, they actually fused back together. And I think there was a picture there where I had a rock with 4 pieces on there. And in just about 6 months, those 4 pieces actually grew fused to the size of maybe a large grapefruit, which would have taken 12 to 15 years, and that was all done in about 15 months.
One of my favorite coral stories, when I teach my students about coral, I have pictures of diving, and I found this huge boulder coral, and it's probably like 4 or 5 feet tall, and there's a picture of me, I'm standing, or not standing, I'm floating next to it, and it's about my size, and I tell them, you know, this is really cool, but this probably won't last, because unfortunately that's what we're seeing, you know, and the corals that we do see now are nowhere near that size. So that's really incredible that you're being able to grow these corals that usually are pretty slow at such a high rate.
Yeah, most of these types of corals are what built up, especially the upper Keys, is what we live on in the Florida Keys. And you know, starting 13,000 years ago, this is what built up as the coral reef, which now becomes the Florida Keys. And so some of these sizes of corals, like you said, the size of a boulder that you may have been the same size, may have been a few hundred years old, some of them even a few thousand years old. And these, if they sexually reproduce, only had to be successful maybe once every 100 years. But now that we've lost so many corals, we don't want to wait hundreds of years for the new ones to come in. Instead, if we can give these a jump start by seeding them, just like we do with forests. If a forest burns down, we don't want to wait 100 years for it to grow back up. People who are in the forestry business plant the trees and get it in a few years. We're doing the same thing with the existing boulder skeletons of some of these other corals and being able to put new live tissue on it to sort of bring them back to life and not have to wait hundreds of years for this to happen. Ken and I are at the age where we don't want to wait for hundreds of years to see these corals come back. We're trying to do it in our lifetime, and it's working.
That's incredible. So you talked about one of the threats was climate change, and you talked about it can go both ways. Cold water can be dangerous, and then warm water can be dangerous. And you kind of mentioned bleaching, but can you tell us a little bit about bleaching? What is bleaching?
Sure can. Ken gave a good example that the coral has a type of plant or algae inside it. That's what gives it its color. If it wasn't for that algae, we would see all corals as their white skeleton. But what happens if the temperature gets very hot or very cold is the algae leaves. And so you're seeing not the color that the coral usually is, you're seeing the white skeleton through the clear animal tissue. And that's what looks like a bleached coral. It's has nothing to do with chlorine or the bleach in your house, but it looks like they've been made white. And when that happens, they're at risk because they lost their ability to gain some of their energy, and they're become very, very susceptible to any sort of bacteria that may be in the water because their immune system is also compromised. And so when we get high temperature events, like it's bleaching, there's a good chance we'll have some diseases within the next few weeks to few months. And we used to have bleaching by historical records estimated maybe once every 100 years. However, with the past 14 years, we've had bleaching about 12 of those, 2 of them being fairly strong years, 2005 and this year as well.
So, Ken, do the branching corals bleach at the same rate as our orphan corals?
The orphan corals. Sorry, that caught me there for a second. The staghorn and elkhorn coral don't tend to bleach quite as fast as the brain corals and the star corals, but some of the other branching corals, the Porites, which is a finger coral, is one of the first ones to bleach. So they can all bleach, and you know, they're this year in particular, the upper Keys anyway, just about every coral bleached, and yet not all of them bleach, and that's one of the things that we've spent time with in our this summer, especially when we had a real bad bleaching event, is we went around and looked for the corals that we've planted, have they bleached throughout the area that we've planted them. They didn't all bleach in our nursery, so you can run down the rows of corals in our nursery, and some genetic strains are very susceptible to bleaching, and others weren't phased by it at all. And so then we went out on the reef and said, are those same corals that are not bleaching in our nursery, are they normally colored on the reef where we've put them? And in some cases, yeah, they were. So we're looking for bleach-resistant corals in our nursery, but we're also looking for them on the reef too. So we were actually adding new genetic strains of elkhorn coral in particular to our nursery this summer, based on the fact that we were finding populations of elkhorn coral that were not bleaching. And so that's real important as we move forward. If you can have your nursery full of bleach-resistant corals, genetically predisposed to not bleach, then when you restore an area, it's going to be a much more hardy population. It's going to be more resistant to the next bleaching event that comes down the line. And that's, that's not rocket science, but it's not solid either. Sometimes why did it bleach? It might have been, and a coral can bleach as a result of several things. One is that the animal itself could be bleach resistant, the genetics of the coral itself, but it could be the genetics of the symbiotic algae living in the coral. It could be the bacterial community working with the symbiotic algae, and it could be the interaction of all three of them. So we're not sure what.
It's a complex process.
But we're gonna, we're looking for the ones that didn't bleach this year. It's like, well, I don't know why that didn't bleach, but we're going to take that back to the lab. And so we've got geneticists and coral nerd people looking at
coral nerd people.
What's different. So what's the difference between this coral right here that did not bleach and this coral right here that did bleach? And so we're trying to figure out why didn't it bleach. There's still a lot we don't know, but we're looking for the hardy ones. That's kind of the bottom line.
So talking about bleaching, last week we talked about recreational diving, or the week before last. I'm sorry.
Amy was in here, wasn't she?
We did an interview with Amy Slate,
okay.
Yes. But one of the things that we bring our students down here to do are the reef check surveys, and where the students actually go out on the reef and they look at the fish that are there, the corals that are there. And one of the things that they do is they monitor, okay, does this look like it's got, does this coral look like it's been bleached? And if so, how much? Because when a coral bleaches, it doesn't bleach the entire thing. Sometimes it's just a little bit, sometimes it's more. And again, I'm sure it goes into that complex interaction where some bleach a whole lot, some don't. But that's one of the things that we get to monitor, and I'm sure that's similar to what you guys do on a daily basis. So we have a question here. Where are the reefs that are being restored? Are they in different countries? So where all have you guys done work?
Well, Dave and I are primarily working here in the Florida Keys. I'm working in Bonaire and Colombia. I'm doing work in both of those, and we're getting ready to start nurseries in about 10 different countries in the next year. But so far it's been Bonaire, which is kind of one extreme. Bonaire is in the southern Caribbean. It's probably, the jewel of the Caribbean as far as coral reefs are concerned. And then the place in Colombia is probably the pits. I mean, it's the worst conditions of any reef I'd seen in a long, long time. And yet we're having luck in both areas. We've found the right corals to culture and reproduce and put back on the reef. A good example is in Colombia. I mean, this was a beautiful reef at one point. It was just a zigzaggy, elkhorn reef, came right to the surface, miles and miles of this beautiful reef, 99.9% dead. So we snorkeled up and down that reef looking for anything. Every once in a while, you'd find this massive thicket of elkhorn coral that just, for some reason, didn't die. And it's just resistant to the stuff that's being dumped on it every day. And so we would take that back and culture that. Now when we're putting those back, these offspring of that back onto the reef, they're surviving because they can, like, hey, we live in this. This is fine. We like this. It's kind of, I'm the coral talking.
Right.
So, I think it's finding the right corals, culturing the right corals, and putting the right corals back out on the reef is part of what we're trying to say is a strategy for how we can move forward. The disease and stuff that wiped the corals out in the 80s, there's a certain number of those corals that were resistant, the genetic strains, and I think that's what Dave and I are finding is even the brain corals, the orphan corals, if you went out onto a patch reef this summer and looked at the patch reefs, most of the corals were bleached or yellow or something like that, and every once in a while, though, you'd find a great big brain coral or a star coral just as normally colored, just happy as can be.
Right.
And So we're trying to figure out why is that doing so well, and can we make that into a bunch of corals and grow them?
So, kind of going off on this for just a second.
I think I answered the question.
I think so. I think we
went
hit
on
it.
a rabbit trail. Hit it and kept going.
Well, I'm about to go down another one, so it's okay. So you were talking about the disease resistance and how some of them are genetically immune or more resistant to diseases. I think I don't remember if it's soft corals or hard corals, but one of them actually do a mass spawning.
Most of these corals mass spawn once a year, and we've tried to take it. Dave's doing the same thing we're doing. During that mass spawning event, we're trying to capture that offspring. The gametes. We're trying to cross-fertilize between, this genetic strain and this genetic strain. Right now, we're just trying to figure out, how to do it and how to raise them. That's really hard. But I think that we're going to get to the point where we know how to spawn them, we know how to rear them. Now, can we selectively mix and match which ones? Because, like I said, I have 110 genetic strains in our just one nursery, and throughout the Keys, I have about 160 different genetic strains. Dave's got another 30 or 40, 50 in his nursery. So we have some winners in our nurseries, and can we cross this winner with that winner, like this bleach-resistant one with this disease-resistant one, and make a bleach-resistant, disease-resistant coral for the 21st century? I think we can. And so that's kind of the gold standard of where we want to go.
We already have just the ability, as Ken was saying, to pick or select the winners from some of these types of events, whether it's good growth, sturdy growth, making it through one of these high temperature bleaching events. And so we know that these are the ones that could be the winners of the future. We're doing something in addition too. We have a unique system of being able to adjust the pH of the water. You've heard about ocean acidification where the pH will get lower. So we have a system where we're testing some of these at different pHs and different temperatures for the ones we're growing on land. So we'll know exactly the same thing, which are going to be the winners of the future, and to put our efforts in the ones that will be those winners, rather than waiting for many years till they show that they're making it or not. We're also doing what Ken and you were speaking of before, is we've been successful with the very small recruits. There's a picture there of, that's a elkhorn coral that's about a half a year old. You'll see how small it is. It's 2 sizes of the head of a pin. At 3 years old, it's got the size that fills one of those cement pucks that Ken was talking about. And that's way too slow for the normal process. Although the first time, 10 years ago, we were lucky that we got about 11 of them to make it from 1 million eggs. In the wild, only 1 out of 1 million makes it maybe every dozen or 25 years. Last year, we got about 200 to 300 to survive, and they're in their second year now. This year, we're hoping to get about 1,000. So the sexual reproduction of mass spawning may be another tool for us to be able to quicken the exchange of genes from one species that's resistant than another. Right now, we're just selecting the resilient ones that we know are doing well. But in the future, we'll be able to do a little bit more technology of crossing maybe those down the line.
So you mentioned ocean acidification. And I know that's really important for our corals, but can you explain to the people who are watching, why is ocean acidification a big deal when it comes to corals?
I can, and most people eyes glaze over when you talk about ocean acidification. It's such a long word, but it's basically the secondary effect of carbon dioxide. Carbon dioxide makes a greenhouse effect, makes us warmer and colder, the climate change, but it also, when it dissolves into the ocean, actually has a chemical effect that it lowers the pH. It makes it more acidic. And it makes it more acidic using a buffer with calcium. It's a complex chemical reaction, but if you just remember that calcium is the same thing that the coral needs to make its skeleton. It's also the same thing we make our skeleton out of, same thing the fish make their skeletons out of. It's the same thing that oysters, clams, shrimp, amphipods, many of the organisms in the sea use calcium for their structure. And so if calcium is harder to get because it's more acidic, then a lot of organisms are going to have a tougher time in the future. That's why we have to pay attention to ocean acidification as well as climate change.
So we have another question. It says, we talked about having a geneticist on staff, but how big and diversified are the staffs of both of your organizations? Because I would imagine it's not just, you two hanging out on the reef all day. There's a lot of other people that are involved. Can you explain, what are some of the other jobs and people that are involved with this?
Well, I'll speak first, and then our organization and Mote are a lot different for size-wise. You start
Right.
there, but so for a lot of the work like that, for a geneticist, we send it out. We let a geneticist. We hire people to do a lot of the microbiology, the genetic work. We just hire it out. We pay for people to do it. And a lot of times we get scientists that are just desperate for something. That they want what we have,
Right.
and so we're saying, come on down. You can be our scientist for a day, type of a thing. So for most of what we do, we have several scientists on staff that work with us, but a lot of our work is just geared on growing corals and putting them on the reef and teaching people how to do it. It's more of a hands-on. We're not an institution. We don't go out and wear science hats and do sciencey things on a daily basis. We're just grinding out coral, and we facilitate a lot of science work, but we don't actually walk around as scientists. Now, Dave's organization is much, much bigger than ours, and they have full-time, scientists. They have a bigger staff, so he can talk about how many different people you have working there.
Well, we started off small as well. Mote Marine Lab was started by Dr. Eugenie Clark 60 years ago, the first lady of sharks. And you probably heard a few of the other, Jose Castro talking about
Yes.
sharks before. And we have a section of Mote that works with coral reef research. So Mote is large. It's about 130 scientists, about 40 PhDs. We have about 1,000 volunteers and 10,000 members, so we're a large organization. Our Keys operation is mostly focused on coral reefs. We have about 8 full-time employees. And of those, we have about 2 or 4 that work in the field, very similar type of operations like Ken was mentioning. We have 2 or 3 that work on land with the land laboratories. And we don't have a geneticist either, so we farm that types of things out. But we do have, because of it being a laboratory that's open as a public lab, we have over 50 different universities and agencies that come down to our laboratory. We have over 1,000 students a year and scientists that come and utilize our laboratory, not as scientists for a day, but scientists for a week or a month. And so we collaborate and partner with a number of organizations like the Smithsonian, like the universities, and they do some of their research which we help facilitate because of the same type of thing. We have some corals they can use. We have the ability to take them to some of the sites, and we learn from them also of what capabilities they may have in giving us advice.
Right. So I'm going to change subjects a little bit. We talked a little bit earlier about the Diadema. Can you guys explain to me why the Diadema are important for the, and specifically for our audience? What is a Diadema?
So a Diadema is also called a long spine sea urchin. And when I started growing up and diving down here, they were everywhere. There's thousands, millions and millions of sea urchins. And there's still a lot of sea urchins down here, but the Diadema are a real important one. They're kind of like the janitors, the grazers of the reef. And I give the analogy a lot of times, it's almost like in Disney World. If you go to Disney World at any given day of the week, everything is perfect. Everything is nice, painted. It's just nice. It's Disney World.
Right.
Well, but you don't know is that at night, these little guys pop out of tunnels in the ground and they make Disney World over every night. I mean, they paint every edge. They scrape gum off the sidewalks. They give Disney a complete makeover every night so that the next morning Disney looks good. And the urchins were like that too. At night, they'd come out of their little hidey holes and they'd go and they'd just graze algae all over the reef and just clean it all up. Then when the sun comes up, they'd hide back in their little holes. Well, when they all died in 1983, in about a 6-month period throughout the entire Caribbean, about 98% of them died, just toast. So I was living in the Florida Keys then, And in 2 weeks, they were all dead. And we were like, whoa, what? And I was like, yay, I hate those things, you know.
Right. Well,
Well, they were, yeah, they were.
they hurt when you step on
yeah,
them.
and so you didn't really like them, but we didn't realize how important they were until they were all gone. And literally overnight, they were gone, and the algae started to grow. And so they kept the algae in check. Now, there's a battle going on the ocean for real estate, and so corals grow real slowly and occupy that space, and algae grow real fast to occupy any bare space. And the urchins kept the algae in check, and so the corals could grow without fighting with algae, and now they can't. And so it's kind of it's been a, I don't know whether I'm getting it all, but
No, yeah.
So when the urchins died off, the algae started to grow back. The algae now covers a lot of that space. That also inhibits sexual reproduction of corals. So when a coral reproduces, it produces little tiny planula larvae that might float around for maybe for a day, it might float around for a week, but it eventually wants to land. And if that area is completely covered with algae, the coral larvae is not going to be able to land and grow. And so you're not getting new settlement in those areas. So the lack of urchins has inhibited the recolonization of reefs.
And that kind of goes along
Yeah,
with...
and Dave could probably jump in and say more. I mean,
Very
Diadema are real
similar.
important.
Basically, they're the underwater gardeners. They're the ones that are trimming the weeds. And if you fired the gardener, all of a sudden you'd have weedy species overgrowing what you wanted to have grow there. And so we call them the keystone herbivore. Herbivore meaning they're eating the plants. Keystone meaning they're one of the prime ones that take care of most of it. And if you take the keystone one out, it's just like the keystone of an arch or a building, the rest of it starts to crumble. And that's why we think Diadema is one of our keystone herbivores. And why people like Ken and a friend we mentioned before, Martin Mote, and Mote have made Diadema one of the species we're still very interested in helping to restore these reefs.
And again, when our students come down here and do our surveys, that's one of the key indicator species that we're looking for when we're out on the reef, is you're trying to find those Diadema. And the Diadema, you said, are the keystone herbivores. Well, now that they're gone, we're seeing that slack, if you will, taken up by other herbivore fish. And so we were talking with Ladd Eakins, and we were talking about the lionfish. And if those lionfish take out the herbivore fish that are feeding on that algae, there's a very good chance that we're going to see that algae overrun and take over on these reefs and kind of smother out some of these corals.
Yeah, I mean, historically through the Caribbean, in any reef system, it's not just urchins that graze algae. It's a suite of things. And what happened in the Caribbean, for the most part, is we've not as much in Florida, but throughout the Caribbean, is they've eaten all the fish, and so they were depending entirely on the urchins to do the cleanup stuff. And when the urchins died, boy, it was a disaster. And so the whole Caribbean, the whole reef system of the Caribbean changed radically in 1983 when the sea urchins died. That was just such a game changer. And I saw it happen, and we all thought within a couple of years they would be back, and they haven't been back, and they're still not back in the Florida Keys. And what we found out is that everything likes to eat them, and you wouldn't think so, but I joke around a lot. I said they're like chocolate-covered peanuts. Everything likes them. And so when you have a place like the Florida Keys where you still have a lot of fish, then they just eat those baby urchins up as fast as they are produced. Other areas, I've been to other places in the Caribbean where they've done extensive overfishing in their area, and the urchins have come back in some areas, and the reefs are starting to look a little bit better, and it seems like there's hope there. But in the Florida Keys, it's going to be a long haul, and so we started this idea: can we grow those urchins and repopulate them that way? And we started down that path, and Dave and Mote has been working on it, but they're a very difficult critter to grow and raise. Extremely difficult.
Kind of funny because I first thought that urchin aquaculture was going to be an easy one to try and crack, and that coral growth was going to be very difficult. And here it ends up that we both come on both branching and reef building corals, ways to grow them in large numbers and successfully starting to restore reefs. And yet we haven't made those kinds of advancements in the Diadema or the long spine sea urchin. So we got to keep hope up with that, because if you would ask the two of us 10 years ago, can we plant thousands or even millions of corals? And we'd say, well, maybe. Now we can both say yes.
Yeah,
With
piece of cake.
Diadema, we still can't say that yet. Some better work on it.
So we were talking earlier, you kind of made the joke of, well, you know, back in the 80s, you didn't have to worry about people stepping on the corals or touching the corals because of all the Diadema that were there, because they do have these long spines, and, you know, I kind of joked about it. They do really hurt when you get poked by them. So now that these Diademas are gone, and we have lots of people stepping on reefs or touching reefs, what's kind of been the impact of recreational divers or tourists out on the reefs touching these corals?
Well, you're right. If you remember that almost everybody before used to cut up an urchin because there were so many of them just to attract fish they could take a photograph. And nowadays, unlike, you almost have to point out where a sea urchin is, of this type of long spine. But before that, there was 3 to 5 in a square meter. So picture a square yard, and there was 3 or 5 of them. So picture these 3 or 5 spiny pin cushions. You wouldn't want to step there, and you wouldn't want to back into it. So we never had to, until recently, have this as an education outreach to tell people, don't back up into the coral, don't step on the coral. Because before, the Diadema were as a one experience event.
Yeah, it was obvious. You did not want to get anywhere near the reef when the sea urchins were there. It was just a canopy of spines just going like this, just waiting for you to get close.
And I'm sure people that are watching this that dive all the time are kind of giggling and going, oh yeah, been close to one of those.
Yeah.
But people who have never seen them, Google it. If you've never seen this, you guys should Google this. But they really do. I mean, they're these crazy long, pointy spines, and
they break off and stick in you.
And I definitely, if I was diving and I saw a bunch of them underneath me, I'd really work on my buoyancy that moment. So that's one of the things that we kind of joke about, but it is very serious. And what happens? Can you guys explain to me what happens when somebody touches a coral?
A good analogy is if you took a coral. A coral is like a fleshly jelly type of animal, and it sits and makes its own calcium carbonate shell, really. But the shell, if you look at most of the reef-building corals, look like little tiny razor blades. So it's be as if you had a grape on top of a set of razor blades. If you basically barely touched the grape, you wouldn't know it, but it would probably make cuts in the bottom. That's what happens if a person would push against a coral polyp. They might look at it and say, oh, I didn't bother it, but maybe the next day that coral polyp may not be a survivor.
Yeah, they've pushed the soft thing against a hard thing and cut it all up, which then causes a bacterial infection of the coral, which then causes a disease outbreak, causes the coral to die.
And it may not have been a problem when we had one diver visit a reef, every so often, but now we have so many people enjoying the reefs. And first-time divers, if they're not trained in buoyancy control, may have 1 or 2, maybe even 3 encounters with a reef by kicking their fin or dragging their extra regulator and not even know it. So it's important now with thousands of users of the reef that we have abilities that we're not having thousands of encounters with the reef.
Right. So we're about to wrap up. So how can people get involved in organizations? How can everyday people come? Can they volunteer? Can they donate money? I mean, how does that work? Say I'm from Tennessee. Say I wanted to come down here and help rebuild the corals.
Well, let's get one question answered first. You can donate money.
We're both nonprofit organizations. We can get donations from anybody that's tax deductible, and probably the best way to do it. In both organizations, you can volunteer. Ken's got a little bit more elaborate and experience in volunteer programs than we do down at the research lab. But both of us require, really the missing thing is financial support.
Yeah, but we do, a lot of schools come down and we do school programs. We have a 1 and 2 day classroom session that we run on a regular basis, and it involves classroom session and then diving in the nursery, diving on the reef, planting corals. So we run about 1,500 people a year through our program planting coral. So it's a one-of-a-kind thing. I mean, I don't know, I think you've done some of that down there at Mote, but It's a great experience for young people that know how to dive. Unfortunately, you do have to be a scuba diver to do it, and there's just no way around that. You don't have to be a scuba diver to see Dave's facility though, so definitely, you know, a lot of times people come down and they work with us a few days and they work with Mote a few days, and then they, you know, there's other things to do in the Florida Keys.
And you said that you've got a land-based well, so can people come and tour that land-based facility?
They can. Since it's a research facility, we'd like them to call ahead so that we can accommodate them, because on good days of diving, most of us are out underwater working as well.
I don't blame you. All right, guys. Well, I'm really glad you both came. Do you guys have any final thoughts and comments?
I think if there's a final comment that, and Dave would probably echo it, is that we think there's hope. We think there's things that can be done. We think that there's a lot that can be done. We need to be doing it, not sitting on our hands, worrying about all the things we don't know about. That there's a lot we do know about, and there's a lot we can do, and that's what drives us, is to take the best advantage that we can of what we can do right now, and learn what we don't know. Right. But
right.
That's true. It's not
there's
all
a lot of
bad
hope.
news about corals like everybody else is talking about. There's hope. These are two technologies that we've both been successful at. They both need to be pushed forward with financial support, and we can do reef restoration in our lifetime.
Well, that's great positive news, because I do feel like nowadays when you hear about climate change and ocean acidification, it's all bad news and bad news. But there is hope, and that's exciting.
Yeah,
it's exciting. Well, guys, I really appreciate it. Thanks for sitting down and taking some time to talk to us.
Thanks for
Pleasure.
sticking it out down here for how many days you've been here.
Oh, not a problem. We've only got a couple more to go, so it's been an adventure for sure.
All right.
All right, guys. Well, join us next week for Bruce and I, our wrap-up session.
People have asked me what it'll cost to restore all the corals back the way they remember. But I have to ask them, what will it cost if we don't do anything? Our reefs are less than 1% of the ocean, but again, they're responsible for over 1/4 of the world's fisheries. If we don't have our reefs, we lose our underwater habitat that allow fish and shrimp and crabs and lobsters to survive. So if you like eating seafood, we have to keep our reefs in good health. Also for tourism. It's a wonderful place that's worth an economic value of near $1 billion here in the Florida Keys, worth possibly $5 billion in the state of Florida alone. Almost all people doing science and research on coral reefs are monitoring how bad condition they have gotten in the past 30 years. We're doing something very unique here at Mote by using technologies of aquaculture underwater to replant reefs the way they used to be, instead of waiting thousands of years for Mother Nature to make that happen. We have found methods to grow corals many times the speed in captivity, so that we can replant thousands of pieces of them called fragments that will make full colonies, and in the future, hundreds of thousands, even to the tune of millions in the near future. The coral restoration process at Mote's Tropical Research Lab, the last few years just having exponential success and growth. We now produce thousands of pieces. We've had corals out in the field for years with 90% survival, and you can see the difference out there. And I can see in just my lifetime, we will replant these reefs the way I remember them being, and many of you also.
Classroom Under the Sea is made possible through the generous support of Diversity in Aquatics, the project's official sponsor. To learn more, please visit diversityinaquatics.com. Additional support comes from the Roane County United Way. Classroom Under the Sea is presented by the Marine Resources Development Foundation on Key Largo in the Florida Keys, and Roane State Community College, one of Tennessee's community colleges.